All right, thanks everybody for joining today. We have the first of the two related talks. Today it's going to be Doug Southworth from International Networks at Indiana University, and he's going to be talking about NetSage. And then next week we're going to have the team from ESnet talking about a related and similar effort called Stardust. So I'm going to throw it over to Doug, and he said that he would gladly answer questions during. So if anybody does have questions, please type them in the chat room and I'll make sure I interrupt them and we can have a discussion during and after. So take it away, Doug.
All right, thank you, Jason. Appreciate it. Again, my name is Doug Southworth with International Networks at Indiana University, and I've got Dan Doyle on board here as well. I'm going to toss him all the tough technical questions if I get out of my depth. And we do have Andy Lake from ESnet, who is going to be talking about Stardust next week, but we're going to give him a chance to kind of preempt that a little bit and give you a preview of what's coming, since it is kind of we'll say a cousin of NetSage. My involvement with the NetSage project started about 1.5 years, 2 years ago, give or take, when I found out there was going to be a NetSage meeting out of town, and it gave me an excuse to have a work trip. And from there, I got sucked into doing some development. So it's a kind of a project that's become near and dear to my heart. So for people who may not be aware of what NetSage is, I'm just going to do a quick overview, give you some of the inner workings of it, and that will kind of lay a canvas for the rest of the talk in terms of how future incarnations of NetSage may look and the future projects that we've got lined up for it, some of which we've already started developing. So NetSage was designed for measurement of R&E data traffic. There was basically a large hole when it came to R&E networks in terms of being able to see end-to-end kind of performance and visualize how traffic took various paths across the globe, what routes it took. Just because we think that specific data is supposed to take a specific route, is it actually traveling that way? Who are partners with specific institutions? Where are we sending data to? Where are we getting data from? What does the performance look like to those different places? So kind of a large picture view of what a specific institution's data uses and requirements are, and then performance that went along with that. So it's a collaboration between IU, LBNL, University of Hawaii, Manoa, and originally had a focus on the IRNC circuits, but since then NetSage is now deployed in a variety of different configurations at different spots in the globe, and looks a little bit different because it's customizable. So for different use cases, we can make it kind of fit and function in those different use cases. So NetSage was built around answering questions as opposed to just displaying data. I've been around networks and systems for a long time, and collecting data is pretty easy. Viewing data in terms of just looking at moments in time is relatively easy as well. But being able to pick out patterns, being able to look at a large scale, a large amount of data and pick out meaningful things in there, getting a bigger picture of what that data meant in the scope of trying to troubleshoot a performance problem, or just give answers to people about who are we communicating with and how much data do we really send, and is this really that important, or are there things we're not understanding? That became really, really hard. And so we built NetSage around the idea of what kind of questions do people ask about the data? What kinds of things do they want to know when they're looking at network data? So if you look at the left side of the slide there, that's what the NetSage navigation looks like. And it is all arranged by question, because this isn't designed specifically to be useful to network engineers, although it obviously is. We also want to bring in end users and non-techie people. And instead of giving them a bunch of jargon and things that they don't understand, questions usually lead people to where they want to be. Well, what do individual flows look like to my particular organization? Or if I want to look at stuff by science discipline, how could I do that? So I just popped into NetSage real quick this morning and looked at a few different things. This graph over here on the side is SNMP data from one of the links. Well, That's kind of an interesting pattern that's popped up on one of the, this is one of the ANA links. In fact, I believe this is our New York to Amsterdam link. So what is that? I don't know. I didn't have time to dig into it, but it's kind of in the back of my memory banks, and I made myself a note. I'm going to look at that. It's just an interesting pattern that's popped up recently and then disappeared again. So this is this one down here, unrelated, is actually a use case that we recently came up with routing, looking through NetSage. So we have an institution in Singapore that is talking to another institution in Taiwan, but we're seeing that traffic in Los Angeles. There's no way that's an efficient route. So why is that happening? Another one, I've eliminated the institution's names to protect the innocent, but they're doing a fair amount of traffic. In the past 7 days, they've done 2.7 terabytes worth of traffic, 2,800 flows at a really, really low data rate. So why is that average rate so low? So NetSage was built around being able to look at data and then ask these kind of questions, and that allows you to dig in deeper and find answers to them. But you got to be able to see this kind of stuff to even ask the question in the first place. So this is by no means comprehensive. There's actually a few more things out there, but in general, when we look at what NetSage has access to, SFlow right now, we've got the institutions listed there. There's a few more places that we're getting flow data from, and we are working on some partnerships with a couple different places to get additional flow data in. But in general, that's kind of just a generic overlook of the international scene. SNMP, pretty much the same as above, but we actually do get SNMP data from all of the ANA links as well. So we can see at least traffic counts when we're talking about ANA data. On the regional side, these are the institutions that currently we have regional installs for. GPN's highlighted there because I went onto their NetSage instance and stole their nice little map, so I'd have something nice to look at for the slide. A lot of these regionals are Epic partners, which is the Engagement and Performance Operations Center, which I also have a hand in helping with that. And while partners, one of the things that we work with them on is NetSage. NetSage is not exclusively available just to Epic partners. If you're interested, we can find a way to, package this and make it a product that you could consume. So there's actually Learn is one of our newer partners, and they are almost ready to go. I'm actually really excited to see their data start pouring in. They're choosing the last couple configurations, and possibly in the next week or two, we'll see data coming in from Learn. So there's new installations happening now. It's not something, these are not ones that happened 4 years ago. We're constantly adding installations. So how do you get data into NetSage in the first place? Well, if you want to send flow or SNMP data directly to NetSage, we can handle that. The global NOC has an ingest pipeline that they handle, and then all of those records actually get stored securely by our OmniSoc. And the OmniSoc is a completely separate entity. They are completely compliant with the most stringent federal requirements for data that absolutely has to be kept secure and cannot have cross-contamination with other data sources. So whatever is stored there is 100% secure, or at least as secure as anything in the cyber landscape can be. Another option you've got is you can actually run your own ingest pipeline. We've fully Dockerized this piece of it, and it takes about an hour, maybe 2 hours to set up tops. And it goes through our entire ingest process, and then we get the processed flows. And again, we can host those in the OmniSoc, or there is a third option, I suppose. If you wanted to have your own database on site, you could do that. However, nobody else would be able to see, your data. So that would be purely a local thing. But those are the two main options we have. Send us all your data as is, we can ingest it, or run your own Docker instance. But it's important to note that no matter what, we never have the IP address. Once it basically hits our pipeline, gets processed, it gets not de-identified, and we don't store the full IP. There's privacy concerns that we want to make sure that we are handling in the right way, and that's one of the things. I've got a slide coming up actually about our privacy policy. So the ingest pipeline looks a little something like this. This is simplistic, but it gets the idea across. We take your SNMP, flow, tstat data from archives, perfSONAR, anything we can ingest. That stuff all we discard flows that are smaller than 10 megabytes. We discard those because those typically are emails and other small things that are inconsequential. And again, it just keeps your identity and your personal information safe if we're not looking at very, very small, minute flows. We stitch anything long duration together. So we're currently using NF dump. So you've got those 5-minute capture files. So stitching occurs in the pipeline for flows that exceed that 5-minute. Then we go out and we do some what used to be GeoIP, which is now kind of tagging in terms of finding whether we've, looking for names for IP addresses. We also have our science registry that we're going to talk about in a little bit in terms of tagging. That gives us a little more specificity. And then the last step is we de-identify everything and then it gets stored in Elastic. So again, once it's in NetSage, once it's gone through the pipeline and we actually store it, we don't have any IP addresses. The reason I keep repeating that is because people don't want to be sure their data is secure and everything's private, but then they see NetSage and they ask, oh, I want the specific though. I want to know exactly what this IP address is. And we can't tell you that. We don't have it. So we are fully GDPR compliant. We are able to work with entities over in Europe and satisfy their privacy concerns. Again, some of the stuff I've already talked about, we discard certain small flows and those kinds of things. Our privacy policy and retention policies are available to anybody. We're not trying to hide anything. We just want to make sure you know that whatever you give us is secure. So the global science registry that I mentioned, this helps us map specific flows to specific resources. So a lot of things in the R&E world, DTNs, perfSONAR nodes, compute resources, they don't have a human recognizable name out in quote unquote the real world. But we want to be able to map those flows when we see them, as opposed to just being down to an institutional level. It's a lot of times very helpful if we can say, well, this is actually a specific DTN at this institution. So think of it as kind of a hyper accurate DNS that is somewhat unique to the NetSage product. Contributions come from resource owners primarily. Sometimes we do a little digging and a little, research of our own if we see something we don't recognize that is moving a lot of data. But usually we go to the resource owner and say, hey, what is this? And could you give us some more information about it? Currently, we're matched by IP addresses. We do have some things in the work that'll give us a little more specificity that we'll talk about later in this presentation. But for right now, it basically is matched by IP address. And we do recognize that sometimes a single IP can represent a host of different things. So that's why we're working towards more specifics in the future. So I mentioned packet marking in that past slide. Packet marking is a relatively new initiative that has come out of the LHC crowd in terms of being able to specifically identify flows beyond just at an IP address, because LHC is starting to come across the same kind of problem. How do I know that this traffic from this specific IP address is really part of the Atlas project, or is it CMS, or is it something else entirely? It just happens to be coming from that IP address. We can make assumptions, but we'd like to know for sure. We'd also like to know for sure whether that traffic is production traffic or if it's test traffic. So the initiative, Sean McKee over at University of Michigan is one of the heads of this, and then Mariam Babik at LHC. And basically what they're doing is they're using some open space in the IPv6 header to say specifically that this is Atlas production, or this is Atlas test, or this is high luminosity test. They can use a series of bits to positively identify it. And ideally, those will just go through the entire path. And at the other end, you'll be able to strip those off, know what it is, and then store the flow information alongside of it. It doesn't work with IPv4 because there's no room in the IPv4 header. So there's a specification already developed for all of this. There's a few technical hurdles that need to be overcome. Honestly, probably the biggest one right now is making sure that the different manufacturers respect the extra stuff that's in the header. I mean, in terms of the RFC, it should work, but will that traffic actually flow from point to point? That remains to be seen. So we're still working out a few different kinks, but it looks promising at this point in terms of getting that specificity we're looking for things like NetSage. An IPv4 option, since we can't put anything in the header, is to use something called a Firefly Packet. And basically, it's a specifically crafted UDP packet that has the same source and destination as an associated flow. And it's got a very specific destination port. And so this packet has a small payload that has a syslog header. It's got some JSON formatted flow information inside of it. And you send this out at the same time the flow starts. You send it out when the flow ends, and you can actually paste packets in there. It's just to make sure that they're getting through. And this type of technique has actually already been used. One of the first data challenges for LHC high luminosity is wrapping up. They're doing a tape challenge wrapping up this week. Last week, they did a data challenge. And ESnet had actually set up a collector and was able to extract all this information in a syslog format. So this has gone beyond the theoretical stage and is actually in use. And again, it's just a way to associate and identify flows, specifically saying this specific flow actually is this specific thing. So there's a couple different options out there. And what that's going to allow us to do is to match flows in a very specific manner in terms of NetSage, once we're able to digest this kind of stuff. But we still don't have a record of the IP address. So we can point to it because it came in an ingest and we can match the flow. We can say, yes, this specific thing is, this specific flow is this specific project, or it's specific type of test data. We can give you that specificity, but we still don't have your IP address. So we can give you the detail that you want without actually having to break any privacy. So LHC, I've mentioned that a couple of times, is one very, very prominent use case. The Data Mobility Exhibition, which is an ESnet project where we get to see the actual speeds of transfers to well-maintained DTN resources and get a handle on your actual transfer speeds. Those DTNs, again, they do other things. They're not just DME DTNs. So if we can sort out that traffic and say this specifically is DME traffic, that makes analysis a little more useful. Or the International Data Mover Challenge, same type of thing. We'd like to be able to sort that traffic out specifically. So anyways, back to NetSage. What do we have coming up? I've got a few different use cases I wanted to talk about today, and all of these are in various states of getting off of the ground, and it's actually been somewhat recent in a lot of these discussions. The first one we were going to take a look at was NetSage for Campus. So the campus use case is a little bit different than, say, international circuits, because on an international level, we can get you down to a facility, possibly a specific building, occasionally down to a specific resource. But in general, it's a more broad ability to see trends between large endpoints. The campus use case is a lot more specific. In fact, we're working with I'll leave the university name out at this point because I don't know if the cat's fully out of the bag yet, but we're actually actively working with a large university who is going through a network upgrade. And one of the problems that they're facing is the people who are in charge of the network upgrade are basically telling them that you don't really need your old science DMZ anymore. We're going to build this new network and it's going to incorporate all of your use cases and everything will be fine. Well, we know from personal experience that the science DMZ is still a very important part of any scientific workflow, especially when you're talking about large data movement in and out of data centers, you know, highly capable, high-speed DTNs that need to be able to push data across the globe. The science DMZ is very important. But what they need is data to support that use case. They need to be able to go to the powers that be and say, look, this is how much data we're moving back and forth just on campus. And these are the very specific types of things we need to be able to do. And on top of that, here's the data that we're moving outside of the campus. And here's all the partners that are ingesting that kind of data. Those type of questions aren't really easy to answer from just say an SNMP counter on a switch, or the flow records from your edge of your campus facing outward. So we're looking at something that is kind of the opposite in some ways of the international use case. We want very, very granular information about how stuff is flowing to and from east and west on campus. And then also that north-south data movement in and out of campus, once it's been moved to the high performance computing center and processed, and then it goes to a DTN, who's accessing that data on the outside once it makes that full trip inside. And is the traffic on campus and outside of campus flowing like we think it is? We've designed it a specific way, but have we missed something and now that data is taking a less effective path? Is it actually staying in the science DMZ? Is it flowing some other direction? Are researchers using their workstation to transfer large files? Are they using the DTNs that are designed to handle those? All that kind of information requires you to pull data from a bunch of different sources and be able to look at it kind of from a higher level and make determinations about what's really happening on a campus. And so in this specific use case with this university we're working with, we think this will give them the information to make their case that over this 5-year network upgrade, they still need their science DMZ. So how does that affect maybe your particular campus? You've already got data, you're already doing collection, maybe you're even doing some flow analysis. Collecting the data is usually the easy part. Again, getting a meaningful kind of insight into what that data actually means in terms of day-to-day performance, day-to-day interaction with users, that's a little harder. Are patterns easy to find when you're looking at that data? NetSage was built specifically to make patterns stand out, to make things that usually get buried in the pile of numbers visible and human readable. The other thing is traditional network tools honestly usually get confined to just your CI folks, right? The people who have a hand in network management are the ones that have eyes on that data. The campus model for NetSage would actually put this data out there in a format that's understandable for researchers and for end users so that they have an idea how their data is moving. They can start to spot performance problems. They can see that for the past year, they've been able to transfer data in and out at this specific data rate, but in the past 2 months, all of a sudden that data rate is now a quarter of what it used to be. Those kinds of things most campus engineers don't have time to keep a specific eye on. But if you give the data to the stakeholders, they can start keeping an eye on their own processes and their own data use models. And the other thing it does for them is it gives them the case for what they need in the future. If they're looking for a CC star type of grant, or if they're going to people on, at higher levels and saying, look, my research is really getting stagnant because I can't move data fast enough. I don't have enough storage. The compute is taking too long. Those kinds of use cases, they now have data to back up that use case and to see what kind of data they're actually using as opposed to just guessing at it. So what needs to happen to make this happen? A lot of the NetSage dashboards that we have in place, a lot of the framework that's built already answers a lot of the questions and scales down nicely to that campus use case. There's probably some tweaking. There's probably some things that need to happen in terms of, you might ask a little bit different question about, data moving between 2 buildings than you would be between 2 continents, but those are relatively simple tweaks to the existing suite of dashboards that we have. One of the big changes is the science registry really becomes kind of the sole source of information in terms of matching flows, because opposed to using DNS and just getting computer names, we want something more specific in terms of being able to say that these 5 IP addresses are all associated with this one particular instrument. And when flows are going from this IP address, they're associated with this project, but maybe from this other IP, they're associated with a different project. So the science registry becomes kind of a larger piece of the puzzle in terms of identifying where stuff's coming from and going to. We also are going to take out that de-identification piece because really it's no longer necessary and it's not actually something you'd want in the campus scenario. You want to have the specificity down to a specific IP address. And so In the campus model, as opposed to this being open to the public, ideally what would happen is this would be behind some sort of either shibboleth login or maybe some other federated login setup so that you still maintain privacy. But again, this isn't necessarily as outward facing as the normal NetSage instances that are around today. So there's some retooling that needs to happen. And there's definitely a lot of coordination that would have to happen with the campus to put this in place. But some of the groundwork has already been laid, and we're interested to kind of move forward with this and see what fruit that yields. So another use case that has come up fairly recently, and we've kind of had to pump the brakes a little bit just because of timing and just the amount of effort that we can put into any one project at any one time, is the idea of NetSage for specific supercomputing facilities. So there's a lot of shared platform out there now for supercomputing. So you've got things like Exceed, which are resources from, Indiana University and the San Diego Supercomputing Facility and Pittsburgh Supercomputing. And there's some other people in there that are involved as well, TAC's involved. And so you've got these different resources out there that now researchers at small institutions that previously had no access to HPC or large amounts of storage now do. And being able to track specific jobs is possible, but in terms of understanding what the performance looks like when you're putting a job into the grid or pulling a job back out of the grid, you still have to move data back and forth. So what does that look like when you're talking about doing offsite, basically cloud HPC work? And what is the user's expectation of what that should look like versus what's actually happening? So there's a lot of interesting tentacles to shared computing resources and what the end user's experience is and being able to track that. So I mentioned Exceed earlier as an example. There's a lot of good record keeping in there, and there's a lot of ways that you can mine down into data already. I mean, you can see what a project is by science domain. You can see what user submitted it. You can see how many CPU or GPU hours they've used. You can see what kind of storage was necessary. There's a lot of different metrics in terms of compute, but understanding how that data got to the data center and how it got back out and how timely that was, how costly that was, those kinds of things are a lot harder to get a handle on, because now you're talking about things that are outside the scope of that specific data center that the job was processed in. And when you've got people who are working across the country, across the state, maybe across the globe, it gets even more difficult to really model and understand that performance when you have things coming from different endpoints to either one specific endpoint, one specific resource, or maybe a multitude of resources that are all, in the same kind of vein as Exceed or something along those lines. So what we want to do is be able to understand the entire job end to end, from the first data bit going out to how it's processed and then coming back in again to the, whatever the quote unquote final product would be. So this one gets a little bit more sticky because trying to map flows to a specific job is a little more difficult. So we've started laying the groundwork on this with TAC actually. And again, we've kind of had to hit the brakes a little bit just because of a variety of reasons in terms of, personnel and how much effort and time we have available, but it's by no means dead in the water. We just are pushing pause on this while we clean up a few other things first. So one of the first things we have to solve is, how do we take an in-house accounting system? TAC has an interesting one called TaxStats that shows a lot of the data I talked about. How do you take that and correlate those with Globus logs and other flow data so that you can say, this user submitted this job, it took this much compute time, it came in on this link, so now I get flow performance data from the home institution to TAC. And then once it's inside TAC, It's basically on one of their DTN setups, and from the supercomputing side of thing, it basically came from one of 4 large data repositories there at TAC. So that data movement inside the data center, what does that look like in terms of moving in and out of a supercomputing pod? And then once that data is processed and back, what does the performance back to the end user look like? So understanding that entire life cycle of a quote unquote cloud HPC job is a really interesting concept and a very useful one in terms of modeling performance and setting user expectations. But it's going to take a little bit of work to do, but we're confident that with our partnerships that we have, that is a achievable thing. So exciting, probably going to get punted into 2022 at this point, because we're winding down 21, still can't travel anywhere. And obviously we're going to be getting into holiday season pretty quick, when time is even more scarce than normal. Another use case that's come up fairly recently was for LHC. We've talked a bit about LHC already, but they have a rather unique use case that is outside of what the current version of NetSage can offer them. I mean, there's insights that can be gained from NetSage, but there's also a very specific use case that NetSage could be tailored towards. So the data challenge they just did is the first in a series of data challenges for all the LHC sites and prepping for a high luminosity. So high luminosity, when that is actually up and going, is going to use more bandwidth than the ANA links across the Atlantic can currently support. Like, it will saturate everything that's there and still want more. So we're talking about large amounts of data. And as these tests keep ramping up, this first test was to basically stress the network to 10%. And after this one, I think it goes 30, 50, 70, and then 100%, but don't quote me on that. There's a stepped process like that. So as these continue to grow in intensity and we continue to push more and more data, we need a way to visualize how that is impacting the network and how that is impacting production traffic, or conversely, how production traffic is impacting the specific test. And so each site is collecting their own data. They've got SNMP data, they've got flow data for their specific piece of it, but there's no single overarching common tool that allows every site to visualize every other site's data. It's all kind of a, let's compare notes based on, here's what I saw, tell me what you saw. So in thinking about how NetSage might be able to be used for something like this, to help them understand where pinch points are, to have to understand what data movement looks like when you're starting to stress the network out more and more and more, we came up with an idea of maybe NetSage is what they need now, as opposed to the campus use case of very, very specific, movement between maybe IP addresses in the same building or between buildings or something like that. This is actually designed more to give them the proverbial 10,000-foot view. When you're moving data across the globe, when you're using all these ANA links, when you have all these facilities fired up, what does that look like? How does that impact traffic on the ANA links? How does that impact traffic to your doorstep of your specific facility versus other facilities that are maybe geographically in the same region, or maybe not in the same region at all? If we can give them the tools to spot broad patterns, if we can give them the tools to kind of look at it from that high level and say, that's interesting that that link is saturated and that one is not, when this should have been load balanced better. Or this particular facility, based on how much data we're pushing, should have had plenty of bandwidth available to absorb all of that, and yet it's completely saturated. Being able to ask those kinds of questions when you see things from a large high-level view allows you to then grab all that local data that we talked about earlier and start really burrowing down and seeing what happened during specific timeframes during the testing. So NetSage is not designed to replace anything in terms of the end user's data collection and analysis. It's designed to be a supplement. It's designed to let them ask the kinds of questions that they actually need to ask to understand what happened. So we have approached a group of people at LHC during one of the last meetings and proposed this. and got a very favorable response. And we're in the works of putting together a working group to start modeling what questions need answered. That's really the first step in this, is what specific things do we need to know about this data? What's your use case? What do you want to be able to correlate? So getting community feedback in terms of what's valuable to them will help drive the development of the specific dashboards that need to happen for LHC. We're going to need a lot of community involvement just because we need to get data from endpoints. We need to know where the data is coming from. And at this point, by IP address is helpful. We can put that into Science Registry right now. But moving forward a couple of years from now, when the next data challenge fires up, we really packet marking is going to become more and more integral into making this useful in a use case like LHC, because they're going to want to be able to turn off test data, as it were. So if there's a data challenge going on, how much of the traffic that we're seeing across a specific link, how many of those flows are production traffic versus how many are test traffic? So being able to sort through that specific data, all coming from one maybe single IP address endpoint, is going to be useful moving forward. So there's some development in the packet marking group that has to be kind of finalized. There's, manufacturers we need to make sure are on board with passing that traffic the way we think they're going to, and then NetSage being able to digest that. So there's actually a fair amount of work to be done here, but the framework that NetSage is built on is able to absorb that kind of data. It's flexible enough to pivot from its current use case and do something like this. So I'm going to turn this over to Andy for just a minute. I've got a slide from him in here. And so what ended up happening was, birthed out of NetSage, because Andy was one of the developers and a very, very integral part of making NetSage happen in the first place. I'll let him talk about ESnet Stardust, but like I said, these are kind of, we'll call them cousin projects, and I'll move on this next slide. And Andy, it's all yours.
Right, thanks, Doug. Yeah, so as Doug mentioned earlier, this is a little bit of a teaser too for a talk we'll be giving next week during this time slot, kind of about our internal implementation. So basically the history behind it is about a year ago, ESnet was kind of looking at its measurement infrastructure overall, and kind of while we were in the process of doing that, there came an immediate need to replace a legacy flow system to meet the needs of the ESnet 6 network upgrade that we're going through. So we kind of took a step back and looked at a bunch of different options, commercial, kind of off-the-shelf stuff, as well as something kind of based off of NetSage, which we obviously had some experience with. And it wasn't just myself; it was a kind of a cross-group team at ESnet. So obviously, as Doug said, I've been on NetSage for a while, so I might have a bias, but I was not the ultimate decision maker here. And so the NetSage-derived approach kind of held up pretty well, and so that's the path we ended up going with. We kind of named the service Stardust, and so it's been really, really interesting. It's kind of a testament to the flexibility of the underlying architecture of NetSage, in that we had to scale this to our entire backbone network. We had a couple additional use cases that our network engineering team had in terms of like peering analysis and things like that. So that required us to integrate some BGP data, for example. And the way NetSage is structured, it has this nice ingest pipeline, and it actually was a good exercise in testing how easy it is to add new pipeline steps and remove others. For example, for the stuff we have internal, we actually want to see the IPs in some cases and things like that. So basically that was kind of the foundation of what Stardust is. We've had the flow side of things in production for a few months now. Now actually looking to other data sources to bring in. So perfSONAR data, we're going to be replacing our NetBeam service that houses our SNMP data, and it's bringing that in here as well. And have a bunch of other work kind of going on in that space. So yeah, anyways, I'll be talking about that more next week, but hopefully that gives you kind of a rough idea of what it is. So
Thank you, Andy. Appreciate it. And I will be excited to learn a little bit more in depth. I've got a pretty good handle on what you've got going, but I'm excited to learn more about that next week myself. So other crazy ideas. What about NetSage for VLBI? So you've got this huge distributed radio telescope essentially. They have to move data in and out of sites and between these correlators that kind of coordinate all that data and make it usable. So is there a use case for maybe NetSage specifically for VLBI? Possibly NetSage for SINET. SINET's been hurt in the past couple of years because of this stupid COVID outbreak, but eventually it's going to be back fully in person and everything's going to return to normal. So what does NetSage for SINET look like? What kind of insights does that yield that we can't currently get? Now, SINET has amazing monitoring internally, but outward facing, what can we show people that gives them useful, relevant data about what's happening in the SINET network that's easy to understand, easy to digest, lets them pick out trends without getting into the nitty-gritty syslog level detail of things? Maybe you put some NetSage at your house, or maybe you don't. If you've got teenage kids, maybe you don't want to know every flow in your house. Probably not. I've thought about putting here at my house, and I don't know that I'm going to do that. But the real point is anything that you can ask about network data, any question that would require more than just knowing raw inputs and outputs in specific moments of times, there's probably a NetSage application for that, and the pipeline and the underlying infrastructure is all flexible enough to adapt to that. So if you have some crazy NetSage idea, we are more than happy to talk about it, because honestly, it's probably not crazy at all. So existing NetSage examples, if you want to take a look at the full-fledged thing for yourself, just go to netsage.global. There's the IRNC international version there. You'll also see all the regional RNEs that I mentioned are represented there as well. The TAC instance is a good example of a data center type of implementation. So the current TAC instance is not the supercomputing one that I talked about earlier. This is specifically instrumented TAC DTN so that we can see flow data in and out of their data archives there. So this is not the full supercomputing one, but it does show the power of NetSage, at least in terms of being able to instrument DTNs and understand flows to and from storage resources like that. And so the look and feel of all these is pretty similar. Dashboards may be added or subtracted just because of use case. In certain use cases, certain dashboards don't make any sense. Now, if all of this sounds really, really super interesting to you, we actually have an opening on our team where you're looking actively for another role to fill that is probably going to end up having some sort of hand in future NetSage development, along with some other things that we've got going on in the group. So if you're at all interested, if you have kind of that network analysis engineering background or even a programming background, we definitely want to talk to you. That's my pitch for you get to be my teammate. So based on this talk, I don't know if that's if I've scared anyone off or not, but we'll give it a go. So go ahead and contact us, and we'd be happy to hear from you. That position is going to be open for a while until we find the right candidate. And that's it from me. It looks like I've got a little time here to take any questions or comments.
All right, thank you, Doug and Andy and the others on the NetSage team. Really comprehensive. So I'll just put out the reminder there. If anybody does have questions, please pop them into the chat. Jen went and shared links to the NetSage web pages so that people can take a look at that. I'm going to make you work, Doug. So if you want to just pull up your other tab there, my questions are going to be mostly from the standpoint of somebody who's never used this before. So sure. let me say I'm a network operator. Maybe my name is James Deaton. You know, I don't want to be too specific, but he's out there, so we can call him out. So let's pull up the GPN dashboard. If I'm James Deaton, what questions do I want to try to answer about my infrastructure? You know, what are some common things that people, when they look at their dashboard, they're able to see, and maybe go through 2 or 3 quick examples of how to do it to give a feeling of what information you get.
Honestly, one of the, people think about performance, they think about link speed. And of course, we can see link speeds throughout, any of the areas in GPN here. But honestly, one of the most consistent questions we get is, who am I doing business with? I think I know who I'm transferring data to and from, but specifically, as an organization or as a, network operator for an international link, who are my main customers, as it were. And so getting this high level overview of who's sending the most data and who's doing it at the fastest rates turns out to be incredibly useful, because that then leads to other questions. Okay, I didn't realize I was doing that much business with University of Nebraska, or that they were that big of a source. So once you go from the high level, looking at your overall flow data, you can start to break that down by maybe a specific sensor that you want to look at. But usually what's useful is just being able to click and say, okay, University of Nebraska. If I click there, that's going to bring me over to an organizational dashboard. And now I'm going to be able to see, of all that data that they've moved in the past, looks like this is a 7-day period, who are their top specific partners. And so then we start to look at, wow, there's a lot of data going back and forth between CERN and UNL, which makes a lot of sense, because UNL has a huge data archive there as one of the tier 2 sites. But what's interesting is this data might be able to be had from a closer source in Europe. So why are they coming all the way over here? Because this is data being sent by University of Nebraska-Lincoln. So there's a lot of data going from the US back overseas. Is that actually efficient? I don't know the answer to that, but it's the kind of question that a table like this can lead you to. And then understanding what your peak data rates are. They're doing some really nice business here, actually. But if you're seeing consistently really, really low peak data rates, or even average data rates, maybe you need to start asking some questions there about, is my path as clean as I think it is? One of the other ones that's becoming more and more popular over time is flows by science discipline. So when you're talking about CC Star grants, or you're talking about identifying your researchers on campus and making sure that you are supporting the specific types of research that are happening on your campus, what kind of data is actually being moved back and forth? And so the science registry, we have an association with the specific science domain. This page was designed to give you an idea of, here's not only your partners, but here's the specific science domains that are represented there. So by default, we grabbed high energy physics. Obviously, UNL is going to be heavy in that specific business, but you can go in here and pick any of the normal science domains and see what kind of traffic you're generating and who your top partners are in that domain. And sometimes we end up honestly getting really surprised by an institution saying, I didn't even know that we were doing business with them. We need to take a look at that.
All right, well, perfect way to sort of spur some more questions here. Mark indicated that he has one, but he would like to ask it out loud. So Mark, if you want to unmute, you can go ahead.
Yeah, thanks, Jason. I'm on a keyboard that's really, really awful. I wonder if you could give me just kind of a quick thumbnail about what the science registry is all about, and whether or not there are any initiatives on to kind of decentralize the identification of traffic. For example, it might be really cool if you had something that you saw come through at 2 o'clock from Indiana University's AS that had tag number 58 on it. Is there anything afoot to kind of decentralize that, so that institutions can kind of do, I guess, more diverse tagging than what might fit in the packets?
So the science registry is an effort, like I said earlier, not just to name a resource in terms of this specific IP address we believe is associated with this specific type of flow, or this is a DTN, or this is an instrument. We also try and peg that to a specific geographic location. We've got latitude and longitude in there so that we know specifically where the flows are coming from. And we also try and tag everything by science domain. So the information that you're not going to get by going out to the internet and doing a KIDA lookup or some sort of other GeoIP lookup, we aim to provide in the science registry, so that twofold, we can get that specificity so you know where your flows are going to and coming from and what science domains they're in, but also so that we can still do our de-identification where you're not seeing full IP addresses. This is all publicly available. Nobody's going to know your IP address and come, knocking on your door in the cyber world because they know you have a DTN there now. We can still keep that specificity while de-identifying data to a point that keeps people comfortable. In terms of decentralizing that a little bit, we don't have any immediate plans in the works for that. However, that is, as we're continuing to upgrade the science registry and I look at doing flow tagging and the specific flow identification we talked about earlier, that's certainly something that could probably be put in the works. I think logistically, that becomes an interesting question of who gets to enter the data, how you're pulling from multiple different instances, I guess is the first thing that would come to mind. If that's decentralized, how do we make sure that it's accurate for all the users of that data? So there's definitely some interesting questions there and probably some hurdles to overcome, but I won't say that it's actively in development, but I won't say that it's impossible that could be a thing in the future either.
Yeah, and just to add on a couple things there. So for one, it's important too to kind of take a step back, and Mark, you're obviously very familiar with like our perfSONAR lookup service efforts, and in some ways there's some similar problems there, right? That this data set isn't that large, for one, and I think a lot of times the use case for like if you have a separate set of data or kind of decentralizing it too is if you have like an internal set of data that you want to add that you maybe don't want to share with people, which can be a use case. But I would encourage, if it is kind of nice having this central kind of public repository where people can add stuff and anybody can kind of pull it down and add things. And really, I think, there's also flexibility at the pipeline layer to add new stages. If you do have some internal database, that has some additional data, maybe relevant to your organization or something, you can add other steps there to pull that stuff in. So there's a lot of ways you can tackle this problem, I guess is another way of saying it.
There were some conversations happening. Sorry, this is Dan Doyle. I work on this as well, and Doug dragged me along commentary on this. Should have introduced myself. There are some talks about ways to do that right now about specifically the decentralizing aspect of it and making it easier for other people to maintain. Obviously, with this data, when we move in that direction, one of the things that we have to be really careful about is that as this data gets pulled in, we make sure that the right people can update the right things, or we'll end up with everything being tagged Bodie McBoatface, and it won't be particularly useful in that regard. But it is a question that we're actively considering right now.
Cool, thanks, guys. And I have a couple of ideas along those lines, and maybe I'll hit you up separately. We can talk about them.
Absolutely.
All right, well, good discussion on that one. So I have one other question here. The asker has asked to remain anonymous, so I will say that it's my question. What's the current state of NetSage funding? How many more weeks, years, months is this going to be going on?
Jen, I believe you're on the call as well. That's one I'm probably going to toss to you.
No worries. Thanks, Jason, and whoever's asked the question. We're an NSF funded project, so there's always a little bit of a question up in the air about that. And some folks are aware that a measurement and monitoring tool was not included in the latest round of IRC funding. NetSage was built in part because NSF didn't have any way of knowing how the international networks worked or who was using them the way they have all the tracking data they do for HPC resources. The IRC funding at IU is actually still running for about another 6 months. And then we've got replacement funding between EPIC and a couple other projects to stay at exactly the same level of IU resources for the next 4 to 5 years. So we're actually in a really good place, and we're still looking at active development. Some of the projects that Doug mentioned that were in the works, we've applied for additional funding for, as well, some of these more specialized things like working with HPC centers or working with campuses. We're doing prototypes internally and then trying to get some funding to have a broader reach. You know, while the funding landscape grows and shifts, you know, it's still a very much of an active and fully funded project going forward for the next, you know, seriously like 5+ years. Longer if we don't start traveling. So we'll see how the pandemic goes. So thank you.
Yep. All right, I'll put out the last pitch here. If anybody does have any questions, put them into the chat. It sounds like we're gonna see some discussion here about the science registry in the future. Hopefully, maybe just take that to the email list to everybody. I see Joe Breen on here, and I guess the last question that I have, and I don't mean to put you on the spot, Joe, but I will, so I'll end up unmuting or allowing you to unmute your mic here if you want to answer. How does this relate back to the performance working group and the metrics work that's been going on over there? Do you have any thoughts or comments that you'd like to share?
Sure, we're working very tightly with Jen and with NetSage and Epic pieces. Trying to stay very much in sync. The project that we have on gathering the SNMP data is stuff that we ask if we'll ask. This can be contributed to the map that we have that Dan is maintaining there through the GR NOC, and you know, if people are willing to share, if they're working with NetSage or Epic and are willing to share with the community, that would be great too. And we can have that SNMP metrics pieces put in there. Does that answer your question, Jason? Or
yeah, perfect for me.
Okay, good.
I'm not the ultimate arbiter though, so if that makes Doug and Jen happy, then I'm happy.
Absolutely, yeah.
Yeah, it's a very collaborative relationship. In fact, we just had a call today talking about how we're interacting. So we're grateful for all of the work that working group is doing.
All right. And with that, we've used up the full hour. So thanks everybody for tuning in today, and thanks to Doug and Andy and Jen and Dan and everybody who contributed. And as Andy said, next week it's going to be related talk on Stardust, and Andy, Soumya, Ed, and probably some others from ESnet will be talking about that. So we'll send out the update on the mailing list, and we'll post the video link, and we'll talk to everybody next week. Hope you have a good weekend.